All right, acids and bases, worksheet number 4. You learned in the notes on the last page that Bronsted and Lowry had a different definition of the one we've been using. Okay, they said that an acid is a proton or hydrogen ion donor, and that a base is a proton or hydrogen ion acceptor. Okay, what does that mean? Well, in this case, it's saying that, for example, water could act as an acid or a base according to this theory. And those that can act as an acid or a base are called amphoteric. So let's think about water for a minute. Let's use that as our example. So if water breaks up, okay, and it donates one of its hydrogens, okay, what's left? All that's left is this hydroxide ion, right? So in this case, water would be an acid because he donated a hydrogen. What if water acts as a base? That means he's a hydrogen ion acceptor. So water starts out as H2O, but he gains a hydrogen on the other side. So what do we end up with? We end up with what's called a hydronium ion, H3O, with a +1 charge, because what we've gained a positive charge, right? So this is when water is an acid. He loses a hydrogen ion. And this is when he's a base. He's gained a hydrogen ion. So let's look at our example up here. It says we've got this HCO3 with a -1 charge plus water produces this hydronium ion plus CO3 -2. So let's look at our reactants. So right here we've got HCO3 and H2O. Let's find these same reactants on the other side. What's happened to him? Well, here's the HCO3. What's happened to him? He's missing a hydrogen ion. Okay? Where did it go? Well, he must have given that away. Well, let's look at our water. It was H2O, now it's H3O. So it's gained a hydrogen on the other side. Where did he get the hydrogen from? He got it from this HCO3. So the hydrogen was donated to the water. So if this HCO3 is the donor, he's the acid. And if the water is the acceptor on the other side, this makes him the base. Okay, whoever you give your hydrogen ion to becomes the conjugate acid. Let's look at the definition. It's the particle formed when the original base gains a hydrogen ion. This is the base, he's gained a hydrogen ion, so he's the conjugate acid. So pick out your acid, whoever you gave it to is the conjugate acid. And here's the conjugate base, because what's a conjugate base? The remainder of the original acid after it donates a hydrogen ion. So if we've donated a hydrogen ion, what's left over? This is it. Okay, let's look at an example down here. Those are my dogs fighting. Ignore that. Oh my God. Okay, let's look at number 3. We've got CO3 -2 plus H2O produces HCO3 with a +1 charge and this OH with a -1 charge. Okay, so what happened? Who gave away a hydrogen? Well, let's look at our reactants. Notice this guy doesn't even have a hydrogen, so he cannot be the acid. Let's look at the water. Here's H2O. What's left of it on the other side? OH. So that means this water gave away one of his hydrogen. So that makes him the acid. Who'd he give it to? Well, this is what's left of the water, so we had to give it to this guy because he didn't even have a hydrogen to begin with. So that makes him the conjugate acid. That means this is the base and this is the conjugate base. Okay, find your acid, conjugate acid. Then just fill in base, conjugate base. Okay, let's look down at the bottom. It says, what's the conjugate base of H2O? All right, let's go back up here. The remainder of the original acid after it donates a hydrogen ion. Okay, so if I get rid of one of the hydrogens, what's left over? OH What's the charge? Well, I got rid of a positive charge. It was neutral, so now it's negative. All right, what about this guy? This says, what's the conjugate acid of HCO3 with a -1 charge? Okay, so the conjugate acid is going to be what? The particle form when the original base gains a hydrogen ion. So if we're gaining a hydrogen ion, okay, I'm going to add a hydrogen to this. So instead of just one hydrogen, how many hydrogen do I have? 2. So I've got H2CO3. It's negative, but I gain a positive charge. So what happens to those? They cancel out. So I've got H2CO3. You with me? Okay, so you're either taking a hydrogen away or adding a hydrogen. All right, have any more questions? Ask.